How does the twin paradox explain relativity? Imagine two twins. One stays on Earth while the other takes off on a spaceship traveling close to the speed of light. When the space-traveling twin comes back, they are younger than the twin who stayed behind. This surprising result is what the twin paradox reveals about how time works in our universe. It might sound like a puzzle, but it actually shows us a lot about Einstein's theory of relativity. The key idea here is time dilation, which means that time moves slower for objects moving very fast compared to those at rest. When the spaceship twin travels at speeds near the speed of light, their clock runs slower than the clock on Earth. So, when they return, less time has passed for them. This is a direct consequence of the principles of matter and energy, which tell us that energy and matter are interchangeable and that high speeds affect how time flows. The paradox gets interesting because, from the traveling twins' point of view, it might seem like Earth is moving away and then coming back. So, they might expect the Earth twin to be younger. But the twist is that the traveling twin experiences acceleration when turning around to come home. This acceleration breaks the symmetry of the situation. The twin on Earth remains in a steady, non-accelerating frame, while the traveling twin's frame changes during the turnaround. Einstein's special theory of relativity accounts for this acceleration, which explains why the traveling twin ages less. This scenario highlights that time is not absolute. It depends on the observer's motion and frame of reference. The twin paradox was a milestone in science because it challenged our common sense ideas about time and showed that time dilation is real and measurable. Modern technology like GPS satellites also relies on these principles, as they need to account for time moving differently at high speeds and different gravitational fields. In fact, NASA's twin astronaut study involving Scott and Mark Kelly proved this in real life. Scott Kelly spent a year on the International Space Station, traveling fast enough for tiny but detectable effects of time dilation to occur. These effects matched what Einstein's theories predicted, confirming that relativity is not just a theory but a real part of how our universe works. So, the twin paradox helps us understand that Einstein's ideas about how matter, energy, and motion relate are true. It shows us that time is flexible and depends on how fast you are moving. This discovery was a major milestone in science, changing how we see the universe and our place in it.